world, it's Siraj, and today we're going to learn how to use a pre-trained TensorFlow model on an Android device. So this applies to any device that runs on Android. We would train the model on our desktop or on our laptop or on the server, and then we would use that pre-trained model on our mobile device. So there's no training that would happen on the device. The training would happen on our bigger machine, either a server or our laptop. But then the inference, the actual making of, making predictions, that would happen on our Android device. So that's what we're going to do today. And we're doing it for a handwritten character image classifier. So the user would, here's what it looks like. So you draw an image and then you hit detect, and it's going to output the result. And the result is the probability of what that class is. It's a multi-class classification problem. So it's a very, very simple app. And the point of this is to learn how to use TensorFlow with Android. Very simple use case, right? And there are a couple other examples that I'm going to give. But in this example, it's just as simple as it gets. So it's a great way to get started. You can use this repository that I'm going to link to, that I'm going to be looking at here, as a base for any other type of classification project that you want to make. Cool. So that's what we're doing. We're going to write a handwritten character image classifier. The user draws it with their hand and then hits detect, and it's going to classify it. And doing this on a server or on your laptop is good because training is a very computationally expensive process, and it's a very energy intensive process, right? We can't just plug our phone into the wall all the time, but we can do that for a laptop or a desktop. So that's why we do it on those machines. But inference, we can easily do that on our phone. So what I have here is this little architecture image of what this looks like from a high level. We've got two repositories here. We have the Android SDK, and then we have the Android NDK, right? So what's the difference here? Well, the SDK is the standard development kit, and the NDK is the native development kit. What do I mean by that? Well, the SDK is written in Java, and the NDK is written in C++. We use the SDK as an interface to code everything we want in Java at a high level. So that's all of the things that are native to Android, activities and fragments and image listeners. So I'm going to actually go into quite a bit of detail on how Android works. I'm not sure how much you know. I've never really talked about this stuff. So rather than being a flyby, I'm just going to go as detailed as possible. And hopefully, you don't already know all this stuff. Okay, so I'm just going to assume you don't know much about Android. So, right, so Android has a very specific way that things work. There's a very specific way that objects interact with each other, right? You have these activities, and then you have these fragments and image listeners and all of these, and then onClick and onCreate, all of these event listeners for how you would interact with an Android app. And it's specific to a touchscreen-like interface. And so that's what the SDK is good for. You can do all of that stuff in Java. But what the NDK is good for is for working with C++ files. And what is TensorFlow written in? The core of TensorFlow? It's written in C++. So that's why we use it. So we can so we don't have to deal with C++. That's why we have the SDK. But under the hood, the SDK talks to the NDK, which is written in C++. So what happens is, you see these two arrows? So this arrow 1 takes the image, the bitmap image that the user draws, and sends it to this TensorFlow jni.cc class, which is like the main TensorFlow wrapper for Android, written in C++. It takes that image and it turns it into a tensor. So it resizes it into a tensor, gives it to the model, the pre-trained model, which is a protobuf file, which we'll talk about more. But this is a pre-trained convolutional network, and it's going to output the prediction, which is a tensor, back to that C++ file, and then that C++ file is going to return a list of probability values in the form of an array straight to our SDK. That is our Java class. And we'll talk about all of these classes in order from the highest level to the lowest level, but that's essentially what it's doing here. Okay, so that's the example that I'm going to use, but there are several examples of how TensorFlow can work with Android. So this one is probably the most well-documented one that I've seen, but it's called Android TensorFlow Machine Learning Example. Basically, it is a general purpose classifier. So if you have a device, you can plug your device into your computer with Android Studio, and then in real time, it's just going to classify everything that you look at, right? So like this wallet, 29% wallet, That's a pretty bad classification, 29% wallet, but hey, 20% ballpoint pen. And the reason it's so well documented is because it comes with an associated blog post, which has got all of these pointers to work with Bazel and how to set up your workspace so that it's pointing to the right version of the SDK and the NDK. So yeah, all that stuff. But the reason I'm not doing that is because it is more complicated than what we're going to do. But that's a good next step to go to after you do this. Okay, so that's the image classifier example. There's another classifier which is a little more detailed. So it does the same exact thing as the first, but once it's classified the image, it then queries both Wikipedia and Wolfram Alpha for some more data about whatever object it is. So it'll classify an image, like let's say it's a lemon, and then use the lemon as a parameter when it makes an HTTP request to the server, and then it returns a short paragraph description of what a lemon is. So you can see how this can be pretty useful for, now we're getting into apps that are actually useful to day-to-day life. Right, so there's that, and there's one more that I wanted to talk about. They're all really classifiers because, you have the camera on the device, so why not just classify everything? I mean, there's so many use cases for classification that haven't even been attempted before. It's such a broad application, right? So this is Guest Sketch, and there's actually a web app version of this too, but you would draw something and then it would classify whatever it is. So obviously you would need a model that's trained on a lot of different images, not just MNIST, but like a lot of different images. So that's when you'd use something like this. Inception would be a great model to use for this. Pre-trained Inception. I love how they named it Inception, even though it has nothing to do with the movie, but it works like a dream. So okay, anyway, where were we? Okay, so we're talking about installation. So that's what we're first gonna talk about. So again, remember, I'm assuming you've never used Android before. So if you have used Android before, then just skip ahead, like I'm gonna estimate 4 minutes. But okay, so the first step is to download Android Studio. So Android Studio has everything you need. So, there are several things that you could use with Android. You could use Eclipse, the IDE, you could use Android Studio, or you could just use this with Terminal and a text editor. But I'm saying that you should use Android Studio because whereas before it was super buggy, like when I was using it a lot a year and a half ago, now I just downloaded it and I've been looking through it a lot. It's actually really, really good now. Like it takes care of a lot of dependency issues for you inside of the IDE, which is amazing. So you can download it from here. It's available for all the operating systems. And so these 3 steps are the next 3 steps. And actually, if you're using Android Studio, you can do it all inside of Android Studio. You don't actually have to do this from command line. This is if you're using, Eclipse or Terminal and a raw text editor like Sublime or something. But you would download the SDK, and then you would download the NDK, okay, as well as the build tools. And once you have those, you would point those to the right. You would point your workspace to the location of both, so your app knows where to find these repositories. Okay, so that's what we've got there. And so in my Gradle file, I've got this, the target SDK version so that I know where that's going to be. Okay, and so let's see, what else do we got here? Properties, local properties. Gradle is the build system for Android, by the way. It used to use Maven, but now it uses Gradle. So yeah, those are the dependencies that we would use. And then once you've downloaded these dependencies, then you want to train the model, right? So remember, we train the model on a desktop or on a server, and we do that in Python, just like you would even if you weren't using Android. You would first train the model there. So let's go over what the Python file looks like at a high level, and then we'll keep going with the Android app and the code, the associated code. So for the model in Python, let's see what we got here. This is what the model looks like. So this is the Keras version. There are 2 versions. We've got the Keras version and the TensorFlow version, but I'm going to go through the Keras version really quickly, okay? So we're going to import Keras and Python, okay? So once we have those, we're going to build a convolutional network, right? A convolutional net is used to detect images, right? Convolutional nets are used for any kind of image classification or even generation. We can use convolutional nets for image generation. We just reverse the way things work. Like we would use gradient ascent, or we would slice off the last half and then add some kind of add a stochastic node in there so it generates some novel data. We would add a random variable in. See variational autoencoders for how that works, but you can generate new data types. And also, obviously, generative adversarial networks, which I've made videos on both of those topics. See my Udacity Deep Learning Nanodegree course, all on YouTube. Okay, so a couple of methods here. The first one is to load the data, and this is just standard reshaping. We have to, remember, we have to vectorize our input data. What do I mean by vectorize? I mean, we have to take our image, raw image, and then convert it into a tensor format so that we can feed it into our model. And so in this case, it is a 4-dimensional tensor, right? So the length, width, the size, and then the depth, which is going to be 1, right? Because it's only a single layer image. So we reshape it using NumPy's native reshaping functions. It's a float 32, so these are float 32. These are 32-bit pixel values for an image, and out of 255 possible, and then it's got out of 255 possible RGB values. And so once we have that vectorized, we'll split it into a training and a testing set, and that's it for load data. And then for our model, great thing about Keras is it's only a few lines, and we can build a convolutional network just like that. It's going to be a sequential model with 3 convolutional blocks. So we do perform convolution, which is essentially like taking a flashlight over a filter of images and looking for what sticks out. So in this case, it would be the MNIST, the actual digits, right? Because they're black on a white background. So it would detect all of that. And then we perform pooling. So pooling is an operation where we look at an image like an array. So let's say, we've got like 4 different, we've got a square where, each of the values in the array is a different number. And then for max pooling, we would take the maximum value from that square. So let's say we got like 4, 9, 12, 15. We would take that maximum value, which is going to be a 15. So the max value. And that's, opposed to average pooling or one of those. This is just a more often used pooling strategy. Okay, so that I already explained that, so I don't need to go to that. Okay, so we do pooling, and then we do it again. We again perform convolution, and what this is doing is every time it's creating more images and smaller versions of that image, right? And we keep doing that until we're at the very end, and now we've got this very high dimensional 4x4 by 256 dimension tensor, but we need an output probability, right? We need a prediction value or a set of prediction values for the probable classes, multi-class classification. So what will we do? Well, we have to flatten that tensor into a one-dimensional array, which is the list of probabilities. So we'll flatten it, and then we'll add 2 fully connected layers, which are the dense layers. And the last activation will be a softmax function, which is going to output a single value for each of the class outputs. Okay, so that's it for the model. And then, yeah. Okay. Thanks, Internet. Okay, so that's it for the building the model part. And then for training with Keras, remember, it's just 2 lines. We compile the model, and by compile, we define 2 main things. We define the loss function that we're going to minimize. Because it's a multi-class classification problem, we're using categorical cross-entropy. And because and what are we going to use to actually minimize that loss? Well, we're going to use an optimizer, a form of gradient descent, which I have a video on called Evolution of Gradient Descent. And we're going to use ADA-delta, which is an adaptive learning rate gradient descent strategy. Okay, and so once we have that, then we're going to actually train the model, which we do with 1 line, the fit function. So in TensorFlow, this would be akin to defining a session, defining the graph, and then iterating through, defining the for loop where we iterate through all the batches. Here we just define the number of batches as a parameter, the number of epochs. So we do it all in 1 line, and then the training data as the input. Okay, and so that's the first key part, is training. And so the other key part is exporting the model. So once we train it, we have to export it. So we have to export it into a protobuf file, right? A PB file. The PB file is the saved weight file that our model lives on. That is our trained model, right? So once we've trained our model, then we save it as a protobuf file, so we can then use it later. And what is a protobuf file? Well, it is a serialized version of our model, right, with all of the learned weights. And so we do that in this method, right? And this is the way to do it for Android. Okay, so well, actually, this can apply to any type of use case, but it is a general purpose saving function, right? So definitely save this function for later use because you're going to use this a lot, whether you want to use your model on a server with TensorFlow serving, whether you want to use it on Android, iOS. I know iOS has the new, what was it called? Core ML, which is really cool. And I'll talk about that as well, but Android is more used. So I'm going to talk about Android first. So, right. So we write the graph. Okay, we write it, and the write graph function is going to help us define what we're going to call it, and then we do the actual saving, and then we freeze it. And what do I mean by freeze? Well, freezing means we're going to save our weights wherever they are. So our weights are at a certain, they're all a certain, they all have certain numerical values, right? So we're going to freeze them at those values. That means it's essentially like saying, declare these weights as constant, right? So you can't change them. They are immutable variables. And then, so once the weights are saved, we're going to open it again and then resave it using this optimize for inference function, which saves it as float32 values, which are the type of values we need for Android devices. So that's why we save it, open it, and then resave it, and then we'll convert it into float32 and then resave it. So we do it twice, okay? And on the second time we save it, we have it serialized to string values. Okay, so that's it for that. And then for our main function, that's where we call all of these functions that we've just defined. We make sure that there is no out folder. And if there is, if there's not, then we create one. We load up our data, save it in these variables, build a model, train it on the data that we just loaded up, and then export that trained model, and then export that trained model using the TensorFlow's native saver function and the model as parameters to the out directory. And then we can use that save model in Android, in our Android app. Okay, so that's it for that part. And so we've got that part, and now we're going to look at this part. Okay, so let's assume we've trained it. We've trained our model, it's saved. Now what do we do? Well, we've downloaded our SDK and our NDK. We need one more thing. We need something TensorFlow specific, right? The SDK and the NDK are just a part of Android. They have nothing to do with TensorFlow. Remember up here, this part right here with the TensorFlow _jni.cc, that is what Google made. Google made this themselves so that we can use TensorFlow functions on Android, on device. So that's what we need to download. And the way that we download this is to download an AAR file. That is an Android archive file. So what is this? This is a way of archiving the dependencies, all of those that we need, into a convenient little wrapper, like one file that we have to look at. But under the hood, inside of this file are all of the C++ files, but we just don't have to look at them. If it wasn't wrapped like this, then we would have to look at all the C++ files, and we would use a tool like Bazel to build all of them from source. But the great thing about AAR is that it is compatible with the Gradle build system that is made for Android. So we can just download it and then import it into Android Studio, and it's going to know all of those files and it's going to put them in the right directories for us. So there's a lot of great magic happening inside of Android Studio, which is actually very useful, right? It saves time and energy. And I've linked to a tutorial on how to import an AAR file, which is very similar to a jar file. So in Maven, we would use jars a lot more. But in Gradle, we use AAR files a lot more. So yeah, check out this tutorial on how to do that. It's very simple. Okay, so once we've done that, we've got our TensorFlow specific dependencies, we've got our SDK, our NDK, we've downloaded this repository. Once we've done that, we could just literally compile it and run it on the simulator or the device if you have one. One of the reasons I chose this specific repository to demo is because it doesn't require a device, right? Not everyone has a device. You can do this in the simulator because all of these classifier examples that I talked about, like this one and this one, and this one, require you to have a camera. And you can't use a camera on a simulator, right? You need the actual device. It would be cool if you could, use a webcam, but you can't. So this is the most accessible repository that I could find. Okay, so let's go over the steps in this tutorial. So what are we going to do here? We've talked about the Python file and how that works. Now let's go into the Android specific code. So we're going to go into Android Studio and go from a high level to a low level. So we'll go down two paths. The first path we'll go down is the actual visualization path. So we'll start at the main activity, and then we'll iteratively go down the chain of dependencies, DrawModel, DrawRender, and then DrawView, which is the lowest level of what's happening. And that's the draw specific code. And then we'll go over the machine learning specific code. So that is the TensorFlow classification class, and then the classifier class, which it calls, and at the lowest level, the classification class. Okay, so once we've done that, then we'll be able to compile and run our model. So let's start off here, right? So here's the model. Link to it is in the description. Check it out if you haven't yet. Okay, so let's see here. We have this main activity. So, and by the way, I have commented every single line in this code. So there is no excuse to not learn how this code works, okay? Even if you don't listen to this video, check out the link. Every single line is commented very well, okay? Even the dependencies. So what we're gonna do is in the main activity, we're going to define the main activity. So that sounds counterintuitive. We're gonna define the only view that the user deals with, right? Which is this one in the XML file, right? This is it, right here. So the user will, in this box right here, will draw with their finger the number, and then they'll hit the detect button, and then in this text view, see the classes here? We've got three classes. We've got the draw view, that's where the user draws the number, and then we've got this button, this clear button, which will clear the canvas if we want. We've got this detect button, which is going to perform inference. So it's going to take that image as input, send it to our TensorFlow model through the TensorFlow's through the Android NDK, which can access the TensorFlow C++ file on device, and it's going to return the output. And it's going to return that output, and it's going to output it inside of this text view. Okay, so that's like what the visualization looks like. It's a one view app, very simple. And here are our trained models, by the way, right? We've got two trained models. And not just the trained models, we have a set of labels, right? 0 through 9, so that we know what are the possible class labels, because this is a multi-class classification problem. And so we've got two trained models, one for Keras and one for TensorFlow. And we'll be using the Keras one just because why not? But the TensorFlow one will be more accurate, but it takes longer to train. Okay, so let's go into this main activity and look at what is happening here, right? So we're gonna import a bunch of drawing classes. By the way, the activity is how the user interacts with the Android architecture, with the Android app. Almost all activities interact with the user, so the activity class takes care of creating a window for you, which you can place your UI, in which you can place your UI with the set content view when we initialize it in the onCreate function, right here. Okay. So if the more complex your app is, the more activities that you would have. We've got one activity, and that activity is drawing the number and hitting detect or hitting clear and repeating that. That's the only activity. And in this activity, all of those actions are encapsulated. So we've got that, and then we've got a bunch of other dependencies. Each of them is going to be used for classification as well as drawing elements, right? So it's split. Basically, the dependencies either draw what we're looking for, or, let me make this bigger. Can I make it bigger? Yes. Yes, I can. You can do anything that you dream. Unless it's crazy. Well, even then you could, with the right amount of computation and training. Okay, so let's see. Okay, so now let's look at the main activity. So for the main activity, we've got our UI elements, right? Those buttons that I just showed you, as well as the views, right? We've got a set of views, we've got those UI elements, and we've got our coordinates. So let's talk about each of these in order. Okay, so the pixel width is the width of our image, 28 by 28 pixels. The button, all right, we've got two buttons. The class button is the detect button. The clear button is the clear button. The text view is what shows the output, and the M classifiers is an array list, which is an array with some, it's basically built on top of the array class. It's a list of, so you can perform, getters and setters on an array. And so it's a list of classifiers that we're going to use. So the reason it's a list is because we're going to use two classifiers in this repository, not just one. We're going to use two, one for TensorFlow and one for Keras, so we can compare the results, right? So that's why it's an array list. And then we've got our views, right? So we've got our draw view, which is the big view, and then we've got our DrawModel, which is the smaller version where the user actually draws. And then we've got our set of points, and these are coordinates that the user is tapping, that the user taps, okay? And then we've got the private set of coordinates, which is like a copy of those, but internally, that we can then modify inside of this class. But they're not exposed publicly, so other classes can't interact with them. And this is just good programming practice to have your variables that are not going to interact with other classes, set them to private, because otherwise things can happen that you don't expect, where you're calling a class, but it's not. And then it's going to modify some variables, but because you haven't set it to private, it's going to, because you haven't set some variables to private, it's going to modify those variables. And you don't want that to happen. So you have to set them to private. Okay, so we've got that. And now in our onCreate method, which is like the basic building block for an activity class, it's going to run only once for the entire lifecycle of the activity, right? And we've got a bunch of these activity-specific lifecycle methods. But the first one is onCreate, and it just runs once, okay? So we've got that, and so now let's go ahead and create an instance for this main activity. And once we have that, we're gonna say, okay, so let's get that drawing view. So we define this in XML, so we're gonna call it by its ID that we define in XML, store it in DrawView. Do the same for the model, and then we're going to set the model. So we're gonna take that view and set its model to that DrawModel. So we're basically encapsulating it inside of that view, and then we're going to create an on-touch listener to activate whenever the user taps it. And then we're also going to do the same for the clear button as well as the detect button, okay? And then we're going to do it for the view. So this is just us wiring our XML to our class, our programmatic class, so we can then manipulate these values. And then we've got a couple of functions here. We've got our onResume function, which is assuming that the user has gone out of the app. It's going to call this and call these methods, which basically it's a way of saving our state and making sure that our app doesn't crash. And these are just basically like, they're like exceptions. They're like Android-wide exception rules. So it's like saving where we are. And so we've got that, and now let's load our model. So this is going to create a model object in memory using the saved TensorFlow protobuf model file, which contains all of the learned weights. So it's going to take these weights and it's going to save them into this mClassifiers array list array, so that we can then use them. So it takes those saved weights in local storage on Android's device and saves them into memory. So it's an in-memory array list that we can then perform inference with. And so we have a try-catch function for that, because if they're not there, then we have to say, hey, there's an error initializing these classifiers. Okay, so then we've got this onClick method. So this is whenever the user clicks on anything. So we have a bunch of if-then statements to define where, if the user clicks, what happens. So if the user clicks the clear button, then we have to clear the model, reset it, and invalidate any new entries that the user does. And then we set the text to empty, like nothing is there anymore. Now, if the user clicks the classify button, then we're going to take the array of pixels, right? So we get the pixel data of everything that the user has drawn up to that point, and we store it in a pixel array. And then we say, okay, we'll initialize this string as empty because we're later going to fill it with the output prediction. And then we're going to say, okay, so for each of the classifiers, for both TensorFlow and Keras, recognize, and so I'll show you what this recognize function does, but recognize or classify what those set of pixels are, a 0, a 1, a 2, a 3. What is this? What did the user draw? And then take that label, and if it's empty, then output a question mark. If it's not empty, then output the label. And set that into the text view. Okay? So that's the highest level of what is happening. And so now we've got this onTouch method, which when the user moves their finger, draw a line accordingly in that direction. Okay? So we take the action and we store it as an integer, and the actions all have predefined ints, like in memory, or not in memory, but that are a part of Android. So check this out. So if the action that the user has, so basically if the user has touched the screen, which we define with motion events action down, which is a 0. See, these are all predefined in Android's SDK. So basically if the user has touched the screen, begin drawing the line. But if a user has moved, if the user has started moving, then start actually drawing the line in a different direction. So touching it just initializes the line drawing, and moving it actually begins drawing the line more than just a dot. And then if the finger is lifted, action up, then stop drawing. Okay, so then these are the implementations of these functions that we just defined, the press touch down as well as the press touch move. So for the press touch down, we get the coordinates of wherever the user has touched, calculate those positions in memory, and then start drawing the line using where we were before and where we are now. And then in this main drawing function, this is when the user is actually moving their finger, take both of those sets of coordinates, where we were before and where we are now, and then draw a line between those 2 points, and keep doing that every time. Okay, so yeah, and then for press touch up, we just take DrawModel's endLine function, which is going to help us stop drawing the line. Okay, so that's the main activity. And so notice how we have this DrawModel function that is continuously used all over the place. So let's look at what's happening there, right? What is happening in this DrawModel function? Well, in the DrawModel function, we are drawing the model. That's what we're doing in the DrawModel function. So it's a collection of getter and setter functions that we can use later on to draw a character model. So we'll initialize it with a line element, which is it's just 2 values, the x and y coordinates. And then we'll have an internal representation as well to manipulate those values. So we'll manipulate them, and then we'll return those manipulated values back to the public xy values, so then we can then draw them on XML, in the XML file. So for a single line, so we have a private line class. A line consists of elements, okay? So we have a model consists of lines, and a line consists of elements. Okay, so so let me talk about each of these. An element is the line from point A to point B, right? So there are a bunch of elements in a single line. A line is everything that you draw from when you start to when you finish. So a line could be an entire number, or it could be like, you draw the first O, that's a line. And then you draw the rest of so, if you're trying to draw a 6, first you draw the O, and then you draw the curve. Both of those are 2 lines. And inside each of those lines are a set of elements, right? From point A to point B. So and then all of that is a model, okay? The DrawModel. Okay, so model, line, element. That's the hierarchy of what this looks like, object hierarchy. Okay, so we've got that. And so now let's talk about these other functions. So this is our current line, the width and height of that line, and then we have the list of lines, right? So inside of a model, there are lines, and inside of the lines, there are elements. So we're defining arrays for each of these objects. And so we've got a set of getter and setter functions for each of them. Okay, so start line, end line, add line element, get the size of it, get the line, and then clear. Okay, so that's it for our DrawModel. And then we've got DrawRenderer. So we're going down even lower level. So we're going down the rabbit hole of lines. Okay, so for our DrawRenderer class, we're going to say, let's draw all these lines to a canvas. So we've got our render model. And so this is just straight up drawing function. So this is the straight up drawing function. So all of those functions that we define in this main activity, as well as the DrawModel, they are high level functions. They're not actually drawing them to XML. This is how we're programmatically deciding what drawing looks like. This is how we decide what drawing looks like. But then in this DrawRender function, we take all of that programmatic logic and we apply it to XML. So we're going to directly manipulate XML elements in this class. So we're essentially drawing lines on canvas. So we'll first set this set anti-alias function to true, because we want to minimize distortion artifacts. This is just good practice to do. And then we get the size of the line to draw. And then given that size, we create a for loop. So get the whole line from the model object, set its color to black, and then get the first of many lines that make up the overall line. So we get the element size and we say that's a single element. And if the element size is less than 1, that means that the user hasn't drawn anything. So just skip it. But if the user has, then store that in an element object, get the coordinates of that element object, the x and y coordinates. And so for each coordinate in the line, so for all of the elements in the line, we have a set of elements in an array, right, for a single line. Get each of those elements and their coordinates, and then draw them on the canvas using where we were before, where we are now, and then this paint object, which is going to make that drawing black. And then we make the new line. Then we make the new coordinates, the old coordinates, in this last x and last y function. And so that's DrawRenderer. And now we'll go to the lowest level for drawing, which is DrawView. So for DrawView, I mean, this is almost like unnecessary to go over because it's so low level. Like, this is just one of those classes that you should just import and like not even worry about, because there's not really any machine learning specific knowledge here. But I'll go over it anyway, just at a high level. We want to first reset the view so it's empty, to empty the drawing. So we'll hit this reset function, which is going to take that bitmap image of whatever the user drew and then empty out all the pixel values so they're not black, so they're white again. And then this is the setup function. It's a private function where we define the view size, the size of the model's bitmap, and then scale it so it's properly scaled for whatever Android device that you're on. Again, this should be automatic. Like iOS would do this automatically, and when the user begins drawing, initialize the model renderer class and draw it on the canvas. So this is where we initialize that DrawRender class that we just talked about. This is where we take it and we apply it. And so then we draw it, whatever it drew, whatever it says to draw, we then draw it. And then so the rest of these are basically calculating the position of the finger on the screen. So very, very detailed XY coordinates of where your finger is on the screen. And then we draw the canvas using the bitmap, which is the image that we just drew. We release it, which is just memory management. So we release it from memory using this recycling function because Android uses garbage collection, which is a type of memory management technique. So Apple uses retain cycles and Android uses garbage collection. Two different methods. Garbage collection is happening, I'm refreshing my mobile knowledge here. Garbage collection is happening at runtime, whereas automatic reference counting on iOS is happening at compile time. That's the difference. So which one's better? There are pros and cons to both. That's out of the scope of this. This is about machine learning, okay? But if you guys want more, let me know of this stuff. Because I've done mobile development quite a bit before. Okay, so then we get the pixel data, and then for TensorFlow's input. So this is how we define the pixel. You know, every single pixel, we have a for loop. We're going through every single pixel, and we're storing it in that pixel array. So that for all of those other functions, we can use that pixel array for both DrawModel, DrawRender, and even this function, DrawView. Okay, so that's for all of the view logic, and now let's talk about the machine learning specific logic. So it's at the highest level, which is our TensorFlow classification class, and then our classifier, and then our classification class. Okay, so for TensorFlow classification, we'll say, how does this work? Okay, so bunch of Android native Android, or bunch of standard Android development kit, SDK functionality is being imported here. And then we've got this interface. So remember that C++ file that I talked about right here? This is where we import it. Okay, so this is coming directly from Google. This is what they wrote as the bridge between TensorFlow C++ and Android. We import it right here, made by Google. Okay, and so what we're going to do is we're going to implement this class. So this class that we're going to create is an implementation of Classifier. Wait, what is Classifier? Classifier is the public interface for how our app interacts with the classifier. Okay, so publicly we give it a string, so whatever we name it, as well as the recognize function. That is the one public function that we are making visible to all the rest of the app. The recognize function, which is going to take the pixel array as input of the image and then return the classification, like the output. This is a 0, 26% chance, 0, for what's 100 minus 26, 74% chance, not 0, or 74% chance 1, or whatever it is. So, yeah. So it's an implementation of that. So that's the interface for this class. Okay, so what we're going to do is we're going to say, okay, so this is the threshold that we define. So it only returns if it's at least this confident. So it's got to be at least 10% confident of what it's looking at. And if it's not, don't return anything. Right? It's got to be at least 10% confident of whatever output probability that it's predicting. And so we have a set of variables here that we're going to talk about when we implement them. So let's just go through each of these functions. So the first function is the read labels function. So given a saved drawn model, let's read all of the classification labels that are stored and write them to our in-memory labels list. So remember, we have this classification, where is it? Labels file right here, So this is where we read it into memory. So into memory, we say, so for all those labels, initialize them as an array list, read them, add them to our array, and return those labels. That's what that does. So this is the second most important function. This recognizes the first most important, but this is the second most important. And so what this does is, given a model, okay, so given a model and its label file and its metadata, let's fill out a classifier object with all the necessary metadata, including the output prediction, right? So these are all the attributes of the model that we can basically get and set later on. So we've got a name that we define. We've got the input, a name for the input. So we've got a name for the model. We have a name for our input data. We have our name for our output prediction. We have our labels that we just read, right, from storage into memory. And we have the model's path and that's where all the raw asset files are, as well as where the model is. And so that's where this TensorFlow inference interface comes into play, right? That comes from Google. Look at this. All this stuff. This is how we take data and feed it to the model. This is the gateway. This class, this TensorFlow inference interface class, is the gateway between Android's Java functionality and TensorFlow's C++ functionality made by Google. And so this is where we define what that is, and we'll set it to the TF helper attribute. And so how big is the input? Well, we'll define that. We'll pre-allocate a buffer for all of those outputs that come out, right? It's not going to be just one output. This is a multi-class classification problem. We have a set of outputs, so we'll store them all in an array list. Okay, so that's the second most important class. And then remember this public class for just exposing the name, the string that we define. And this is the first most important, not class, function. This is the first most important function. Class, function, doo-wop, Dutch, English. I'm just switching between languages and my mind is like blah, 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 blah. Okay, so then for our recognized class, which is the most important class, here's how it works. Using the interface, we give it the input name, the raw pixels from the drawing, and the input size. So we feed that into our TensorFlow interface, right, that class. And then we check the probability values. So we say, okay, if we want to keep those probability values in memory, which is why it's a Boolean, then feed it those probabilities as an array of probabilities, which we do, so we're going to set it to true. And then we get the possible outputs. So when we run it, we set these output names as the parameter, so it's going to fill those output values. So then we get the possible outputs using the names, which are here, and this is where we pre-allocate the buffer. So then we get those possible outputs via the fetch method. So we first run using those output names, and then we fetch it. Okay, so we take the actual output and the output names, which is the list that we fill with the output. Whatever the output prediction is, we fill it into that output names list. And then we find the best classification from those outputs. So we say, let's initialize our classification object. And then we say, find the best classification for each of the output predictions. If it's above the threshold that we defined for accuracy, write it out to the view in that text view. So we say, okay, for the length of each output, print out the labels just for us for debugging. And then if the output is greater than the threshold, if the prediction value of the output is greater than the threshold, okay, and it's greater than the output, and it's greater than the output prediction that we define inside of that classification object, then update the object with the new output and its label. And then we can write that to memory. Well, first we'll return it, and then we'll write it to memory when we call it. Okay, so yeah, so we talked about our classifier and our classification class. Okay, so one more thing. All right, so the classification class itself. We've got two variables. Conf is the output prediction, and a label is the input label. And so we define the threshold here, 1.0, which is 10%, the minimum threshold, and then the label, which is null. And the only public-facing function is this update function. Oh, and the get label and the get conf. So we two getter functions and then an update function, which is how we update it, which we called right here, right? And that's it. So yeah, if you have an Android device, you can easily deploy it to that, right? Just compile it and then pick one. Also, I want to talk about one more thing. When would you use a model on your device versus on the server? You would use it on the server if you want to constantly deploy new versions of a model. So you'd use TensorFlow serving, right? The con to that, right? Because the con to that is then you would need your mobile device to constantly make HTTP requests. So it always has to be connected to the internet. What you could do is you could have it both ways. So the best of both worlds would be to have an inference model on the device, which is static, right? You can't just update it unless you deploy a new version of the app. So the user would have to update the app. But you could have a version on the app, and you can have a version on the server that is constantly updated, that you can set some frequency to check and then update the model locally using the server. So you should have the best of both worlds. Okay, so let me answer 2 questions to end this, and then we're done. We're done. So the 2 questions are, can you do a video that's like Siri, like how to code the Siri product? So I could. The thing about Apple is they don't really open source anything, right? So we don't actually know what their machine learning, like how it works. I'm gonna bet though that it's okay, like it's not that good comparatively, because in this day and age, if you want respect, if you want credibility, the name of the game is to publish and publish often. And Apple doesn't do that. But how does Siri work? I'm gonna guess that it's gonna use a set of predefined responses on a server, making HTTP requests. It's barely using any machine learning. Maybe it's using machine learning just to, well, it is using machine learning to detect your speech, but I don't think it's using machine learning to generate responses. If it is, I'd be very surprised. Yeah, so that's the first question. And then one more question is how to train feedback and get their respective rating to predict the rating of new feedback. So that's a supervised classification problem, right? You've got some text, and then you've got a label. And then you want to learn the mapping between the two. And so how do you learn the mapping between two, like a label and an input? Supervised classification, right? This is general supervised classification. The way you do this for text is using an LSTM network, which is a type of recurrent net made for word or for text data. Cool. Please subscribe for more programming videos. And for now, I've got to create a new series. So thanks for watching.